It's a rocket. It's a cannon. It's a spud gun.
Spud gun.
We are the Sweet Potatoes, and we are going to use this spud gun to show how physics is behind projectiles.
A projectile is an object that has a single force acting on it, gravity. There are 3 types of projectiles. The first is free fall.
The second type is throwing a ball vertically upward.
The last type is throwing an object horizontally at an angle. This is the type that we're going to show you tonight.
Compressor takes air and then it packs it all up and it makes it super compressed. And so we have a valve here. The valve is connected to a tube that leads to the outside atmosphere, which is not compressed. That's what we breathe, what we live in. So all of this air in this blue tube and in this tank is fully compressed and it's ready to go. And as soon as we click this, it shoots that air straight through the tube and then down here behind the spuds. And what happens is the air pressure builds up in the tube beneath the spud, and then it just pushes it slowly and then faster and faster, and then it just pops straight out.
This is just our version of a spud gun. The original plan was to shoot t-shirts out, but it was too small, and the other PVC pipe wasn't airtight.
So to fix this problem, we have made a slingshot. With 2 exercise bands attached to handles, we have a solution.
So, we know the distance that the t-shirt landed from where I launched it at. So that gives us the change in displacement. We need to find out the initial velocity of the t-shirt. So we used a stopwatch to find the time from when I launched it to when it landed. So we use this equation right here to find out what the initial velocity is. We're able to know that this part right here will equal 0 because acceleration is always 0 when it comes to this equation due to kinematics. So we can use the time and the displacement that we already know to find out the initial velocity by dividing the displacement by the time. And there we come to the conclusion that it is at 42 meters per second.
So at different angles, you get different distances.
With 32 degrees, it should go about 63 feet.
So to prove this, we have the slingshot pulled back around 32 degrees. And by using the slingshot, it should go the 63 feet, which is around that part of the road. Go ahead and fire the slingshot. Slingshot, slingshot.